All right, let's just dive right into this explainer and reverse engineer the ultimate masterclass in project management. We're talking about the Great Pyramid of Giza. We're going to look at this absolute marvel of the ancient world through the lens of modern systems engineering. Why? Because we really need to grasp the staggering scale and, honestly, the pure scientific genius of its construction.
To understand how this awe-inspiring 4,600-year-old structure was actually built, we first have to fast forward to see how it survives modern catastrophes. Back in 1992, a devastating 5.9 magnitude earthquake hit the Greater Cairo area. It was tragic. It literally crumbled modern homes and steel buildings. Yet, just a few miles away, the Great Pyramid, a mind-boggling 6 million-ton mountain of stacked stone, basically just shrugged it off. It suffered nothing more than a single loose stone. I mean, how is that physically possible? Well, the secret to its survival actually comes down to physics, specifically something seismologists call fundamental frequency. A team of Japanese and Egyptian experts recently placed sensors all over the pyramid to measure how it naturally vibrates. And what they found is wild. The pyramid naturally vibrates between 2.0 and 2.6 hertz. But the soil underneath it, that vibrates at a totally different frequency of 0.6 hertz. This massive frequency gap acts like a gigantic natural shock absorber.
So today, we're going to break down this monumental mystery by looking at 4 key areas: the master blueprint, a monumental supply chain, the multi-method solution, and finally, built to survive millennia. Starting off with Part 1, the master blueprint, focusing on astronomy and surveying. Long before a single stone was laid, these builders had to be master surveyors. And the Great Pyramid's literally perfect alignment, it wasn't just some lucky guess. It was the mathematical peak of an evolving technique. Based on Cambridge University data, earlier structures, like the Step Pyramid of Djoser, actually weren't perfectly aligned. But generation after generation, the architects honed their craft. It peaked exactly during the reign of Khufu, the guy who commissioned the Great Pyramid. And then, strangely enough, the accuracy actually started to get worse after him.
So why did it peak and then suddenly decline? Well, it's because they were aligning these structures using the stars. And thanks to the Earth's natural wobble, the stars slowly drift over the centuries. By using the simultaneous transit of 2 circumpolar stars, basically stretching a plumb line right when those 2 stars aligned vertically in the night sky, these ancient engineers hit a sub-arc-minute cardinal alignment. They did this without ever touching a magnetic compass. The exact year those specific stars aligned dead north, 2467 BC, which is exactly the era of Khufu. Mind-blowing, right? And down on the ground, the precision is just as staggering. To safely support 6 million tons, they actually used the natural Giza bedrock as an artificial hill. They left a massive core of natural rock right in the center to save time and lock in absolute stability. Then, they leveled the surrounding 13.1-acre footprint to a total variation of just 2.1 centimeters. To put that into perspective, that rivals laser-guided modern construction tolerances.
Moving right along to Part 2, a monumental supply chain and logistics.
Now, to actually pull this off, the sheer numbers involved are almost hard to wrap your head around. To place 2.3 million blocks during Pharaoh Khufu's roughly 20-year reign, these workers had to quarry, transport, and lay down 1 block every 2 to 3 minutes, and that's based on a 10-hour workday. Just think about that for a second. Every couple of minutes, a stone weighing as much as a modern SUV was set into its final, permanent position. This wasn't just a building project. It was the most relentlessly efficient factory line the ancient world had ever seen. So how on earth do you keep up that kind of pace? Well, we actually have the receipts. The recently discovered diary of Merer, who is basically an ancient logistics manager, gives us the exact day-by-day routing system. Merer commanded a crew of about 40 men. They would extract this brilliant white limestone from the Tura quarries, load 10 to 15 of these massive blocks onto flat-bottomed barges, and literally sail them down the Nile into a highly engineered artificial lock and canal system right at the base of the Giza Plateau. That entire 15 to 20-kilometer round trip took them exactly 4 days. And they optimized this whole grueling process using a brilliant trick of applied physics. They wet the sand in front of their transport sledges. See, if you pull a heavy sledge over dry sand, the sand piles up in the front, creating this huge berm that totally kills your momentum. But if you pour just the right amount of water right ahead of the runners, it binds the sand grains together and slashes the pulling friction by 55%. That is a massive difference. It meant a much smaller workforce could haul a 2-ton block straight from the harbor to the pyramid base.
All right, on to Part 3. The multi-method solution for construction.
Okay, so this is the part everyone always argues about. How did they actually lift these blocks hundreds of feet into the sky?
For centuries, people have debated over one single master method, but mathematical models prove that a single, massive, straight ramp is physically impossible. Seriously, if you wanted a straight ramp with a manageable 8% gradient to reach the top, the ramp itself would have to be nearly 1.8 kilometers long. It would require 4 million cubic meters of material. That's 60% more volume than the pyramid itself. It makes absolutely zero sense to build a much larger temporary structure just to build a smaller permanent one. They had to adapt.
And this is where the true engineering genius of the Egyptians shines. They used an integrated, hybrid approach that constantly evolved as the pyramid grew taller. There was no single secret method. According to the Cadence AI engineering analysis, the architecture itself literally forced them to change their techniques as the geometry of the structure narrowed towards the top.
When we break down that data, it becomes clear they use short external ramps for the really heavy base courses, up to about 43 meters. Once they lost that wide surface area on the outside, they transitioned to internal spiral ramps, literally leaving corridors inside the structure as they built up. And finally, as the apex got incredibly narrow and the blocks got a bit smaller, they switched entirely to manual levering systems to meticulously hoist those final stones to the absolute peak.
But wait, what about those absolute monster 60-ton granite blocks used for the king's chamber? For those, they essentially transformed the pyramid's own internal architecture into a giant machine. It's highly likely they used the Grand Gallery, which is this massive 47-meter-long sloping corridor inside, as a colossal gravity-powered counterweight and pulley system. By running heavy ropes down the gallery, a heavily loaded sledge sliding downward could literally haul a massive granite block upward through a central shaft. They basically built an ancient stone-powered freight elevator.
And finally, part 4, built to survive millennia. So how does a staggering amount of engineering effort pay off thousands of years down the line? Well, that brings us full circle right back to the earthquakes we talked about. By making such incredibly sound empirical engineering choices, the ancients accidentally created a perfectly balanced structure with built-in seismic dampeners. Think about it. The wide bedrock base, the extremely low center of gravity, that perfectly tapering 51-degree angle, and those intricate internal relieving chambers above the king's tomb. Together, all of these elements naturally dissipate kinetic energy. While modern concrete shatters, the Great Pyramid just absorbs the shockwaves and stands completely still.
Today, we build these gleaming skyscrapers of glass and steel that touch the clouds, but they absolutely struggle against the Earth's natural tremors. The Great Pyramid is a masterclass in adaptive engineering that has stood tall, guarding its secrets, for 4,600 years. It really makes you wonder, what structures from our modern world will still be standing, awe-inspiring and unshaken in the year 6600? Thank you so much for joining me on this explainer. I really hope this gave you a whole new appreciation for the absolute genius of the ancient world.